Now, Chapter 5, Popular Machine Learning Classifiers. In this chapter, we'll study a selection of popular and powerful machine learning algorithms such as logistic regression, support vector machine, decision trees, and k-nearest neighbors. Choosing a classification algorithm is not a simple task in practice. Each algorithm has its own quirks and characteristics and based on certain assumptions. So no single classifier works best across all possible scenarios, which is a basis for no-free lunch theorem. This implies that if you want to get a good model, then you have to get it through comparisons. It is always recommended that you should compare the performance of many different learning algorithms to get the best one for the particular problem. Let's go to section 5.1, Logistic Sigmoid function. The logistic curve is an S-shaped curve with equation here. L is the maximum value, K is the growth rate, and X0 is the sigmoid's midpoint. If we said L is 1, K is 1, X0 is 0, then it becomes the standard one, the standard logistic sigmoid function. S of x is 1 over 1 plus e to the minus x. Its graph is given here in this figure, and the minimum is 0 and maximum value is 1, and it is symmetric about this midpoint. The standard logistic sigmoid function has the following properties. It's the solution of the differential equation. You can easily check that when x is 0, the sigmoid function has value 1/2, and we differentiate it, then we can get s of x times 1 minus s of x. So s of x will satisfy this differential equation. For S prime, you can check this equality easily. So it is an even function. As earlier we saw, it is a rotational symmetric about the midpoint. S of x plus s of minus x is 1 for all choice of x. Its integration becomes logarithm 1 plus e to the x. Is known as the soft plus function. Let's look at the figure. Here, the green curve is the graph of the soft plus function. The blue one is the graph of rectifier, which is defined as taking maximum between the input and 0. So once x is negative, then the output will be 0, as in this the graph. Apparently, the soft plus function is a smooth approximation of the rectifier. And these two functions are quite often used as activation functions. Of course, the sigmoid function is also very frequently used as an activation. Particularly, logistic regression uses the sigmoid function for activation. So here, we want to explain the idea behind the logistic regression as a probabilistic model. Let P be the probability of a particular event having class label 1, then the odds ratio of the particular event is defined as this ratio, p over 1 minus p. Then we can define the logit function by taking logarithm. So logit p is logarithm p over 1 minus p. The logit function takes p, which is between 0 and 1, and its output is any value over the entire real line. So here we may use it to make some connection. So probability that X, a particular sample, belong to class 1. So we write down in this way. The logit of P is its net input. So we have this connection. Then in machine learning, what we want to know is probability, so that by taking inverse of logit, we can write in this way. The inverse of logit and net input will become probability. That's what actually we want to know. So we have to find the inverse of logit function. It's quite easy to get it. Now here, so here now, change this portion to be z and solve for p, then you can get this term. So that is the standard logistic sigmoid function. So here we have conclusion. So if so that means that now that is sigmoid function for that input. If you are using the standard sigmoid function, then that becomes probability. We may consider the output of this activation is the probability. So here, when the standard logistic sigmoid function is adopted as an activation function, then the prediction may be considered as the probability that a certain sample belongs to a particular class. This explains why the logistic function is one of the most popular activation functions. That is the end of section 5.1. Thank you. I'm very sorry I got cold, so that my voice is not really clear today. I'm very sorry. Thank you.